All right, that was just me having a little bit of fun because we're talking about polar coordinates. And today I just want to show you a quick formula. I didn't know that it was going to take that long, so um, I added a little bit of entertainment at the beginning just to see what I can do with these things. Um, the, the, the really the main concept today is slope for polar curves, and I'm going to sort of just give you the formula or show you how it's obtained. Um, and let you use it in the problems that are assigned today. Um, so remember that a polar graph is one where instead of having a lateral and vertical position denoted by x and y, you have an angle and a distance from the origin. So the angle is theta, r is the radius, and what you learned is that you can convert between rectangular and polar using the equations x is equal to r cosine theta, y is equal to r sine theta. But remember, with polar functions, this is going to be like x is some function, r of theta times cosine of theta, and y is some function, r of theta times cosine theta. So what are we going to be looking at for? Well, we're going to need dx d theta. Dx d theta is going to be, I use the product rule, so it's r prime theta cosine theta plus r theta sine theta. Dy d theta is going to be r prime theta times sine of theta plus, let's see, okay, plus r of theta times cosine of theta. And I made a mistake in the last one. The derivative of cosine is negative sine, so this plus should be a minus. So what's the slope? When I'm looking for the slope, I'm talking about what is dy dx. And on a point on that graph, and let's say if I have r is equal to 4 cosine 3 theta, for any point, right, like right here, I might be looking to find the slope of the tangent line using this curve. And I have r and theta, and I want to find dy dx. And keep that in mind. So dy dx is going to be dy d theta divided by dx d theta, which is going to be r prime sine of theta plus r cosine of theta divided by r prime cosine theta minus r sine theta. And you can remember that pattern, or you can remember how to derive it. On the AP test, it's likely that if you need this, you'll only need it once. Sometimes they have an FRQ problem with something like this, but oftentimes they won't. Sometimes they'll have a multiple choice question like it. So you'll need to know this for Chapter 11 and for the Chapter 11 test. And then I would say it's a low priority when you're preparing for the AP test. If there's other things, like if there's volume type questions that you still don't understand, if there's implicit differentiation questions that you don't quite understand, integral as the accumulator, all those things are a lot more important than this. However, if you do feel like you're caught up and this makes sense and you're thinking about what do I need to do to ensure that I get a 5 on the AP exam, well, I would say if this makes sense and you're able to apply it, and you're still able to apply it when it's mixed into tests with a bunch of different types of questions, you're in very good shape to get a 5 on the AP exam.